This section is on 5.5, solving exponential and logarithmic equations. So basically the whole chapter was to help you solve for these problems for this last section. So everything applies. The last section that we learned was about the three different properties. So we will use all those three properties to solve for x. Okay. So when we go about do this one right here, example 1, we have is then 3 to the x equals 20. We want to keep it into exponential form. If you have any logs or ln, try to make it into exponential form so you can solve for it. So we also learn from exponential form to bring down the exponent of x. If we do log on both sides, then that will bring that property of it, because you can't just bring the x down. There's no such thing as that. So we have is then 3x right here is equal to log 20 right here. And so then from there, the property says that in the log property that I have an exponent of x. I can always bring it up to the front right there. So then I have as x times log 3 is equal to log 20. And then from there, I'm just solving for x. So then I would divide both sides by log of 3. So we have as x is equal to log 20 divided by log of 3. So then this right here, it just is in the calculator form. You would just put it in the calculator. So let me just do it side by side so you can kind of see that. So then we have is then you would just enter in log of 20 divided by, and then log of 3. And then you should get your answer of 2.7268. So that would becomes your final answer right there. So x is equal to 2.7268. Okay, so that's it. So again, this is what we're doing. Is we're just solving for x. So that's one way. Now let's go into the other way. So there's many ways to do this. So I'm trying to do is solve the different possibilities so you can see what other possibilities you come across. So example 2 gives us something like this. You have as 2 and then 3x to the minus 7 as an exponent, and then equals 32. So you could do is log on both sides on that, but there's other ways you can do this kind of problem. If you can see that the base of this right here, 32, can actually be changed to 2 to the something base, right? So I believe it's 2 to the 5th, right? 2 to the 5th gives us 32. If that's true, then I can substitute this as 2 to the 5th instead. So then I would have something like this, 3x minus 7, and then I would have 2 to the 5th. The reason why I want to do it this way is because as long as the bases are the same, we can cancel out the base, and you just then are working with is 3x minus 7 is equal to 5, and then you just do the algebra to solve for x, okay? Again, this only applies if both sides of the bases are the same. Now, if I had a plus something or a minus something over here or even over here, you can't do that. You have to have exactly the same amount. It's like proportion. So it's exactly the same amount of base 2 here, base 2 here on both sides of the equal sign to be able to say cancel, cancel. And then I can work with just the exponent part of this right here and then just do the algebra. So then we would add 7 on both sides. You get 3x is equal to what, 12? And then x is equal to 4 as your final answer right there. Okay. Another problem that you may see is something like this. Now, obviously, we cannot do what we just did in example 2 because the base of 4 and the base of 3 are not the same. So we could do 2 to the second power, but again, that does not give me the same base. So in this case, there is no other way but to bring down the exponent of these both. And the only way we're going to bring down the exponent is if we use the log property. So then we would have to do log of 4, and then x plus 3 is equal to log of 3 of negative x. Okay, so now we can bring the exponents down. So then I have the exponent of x plus 3 in the front, and then becomes log 4 is equal to negative x log 3. Now, here's the problem. I have x's on both sides of the equal sign in this case. So what your goal is to have is all the x's combined together and all the numbers together. So in this case, we're going to go ahead and distribute this right here into each one of these. Now you can do that actually technically because it is now like a large, x plus 3 is not an exponent now. It's actually part of this right here. So if I distribute that, I'm going to have then as x log 4 plus 3 log 4 is equal to negative x and then log 3. So can you then see that this right here will combine like terms with this right here, right? Because both of them are now going to be similar. So if I bring this one over to the other side and bring this one now over to the other side, so that way they can combine like terms right here. So if I bring this one over, this is a minus right here, so I'm going to have to add x log, and that was 3, equals, and since this is positive, I'm going to have to bring it over on the other side, make it a minus 3 log 4 right there. Okay, now from here, since both of these have x's, now I can factor out an x right here. So then we have is log 4, and then I guess we can multiply, right? Go ahead and do multiplication right here. So go 3 right here is equal to, and then negative 3 log 4 right here. Okay. So this becomes then log 12 right here. So log 12 right here is equal to negative 3 log 4. So again, we're solving for x. So we can divide both sides by log 12 right there. So it becomes negative 3 log 4 all over log 12. And then this right here, all of this is going to be put in the calculator. And again, why can we put this in the calculator? Because it's in base 10, right? Remember, this base 10 right here, you have to be careful though. So this right here is base 10, this is base 10, so I can put this all in the calculator and get the answer. So the final answer comes out to x is equal to negative 1.6737. So check on that one to make sure you get the correct answer on that one. Okay, now let's try example 4. So example 4, again, it's not in exponential form. We want to make it into exponential form. So we're going to bring our base 3 right here, the log base 3, over to the other side. And you get x is equal to 3 to the negative 2 power, which then becomes 1 over 3 to the second power like this, right? Because if you have a negative right here, you can always bring it to the bottom, making it to a positive exponent. So it becomes basically 1 over 9. Now, depending on what the answers are on the MyMathLab, they may leave it in fraction like this. If they put it into decimal, then you can just do 1 divided by 9 as your final decimal. Okay? All right, so that's example 4. So we go into example 5 now. So if example 5 on the MyMathLab, they give you something more, a little bit complex on this right here. So what you're going to do is you're going to try to solve for this. So again, using the 3 properties that we have, so we know I can consolidate or condense this, right? Because this is a plus right here. So to condense it, I have is log base 10 x times, and then I can put this right here, x plus 3 is equal to 1. Okay, now in previous problems, we didn't have this part right here that equals 1, but we do in this case because we're solving for it. Okay, so again, our goal is to solve for x. So what do? Well, we want to bring this over to the other side right here, and then we're going to have as x plus 3 is equal to 10 to the first power. Now, once we get to this form right here, this is actually algebra 1, because then you can go ahead and distribute, combine like terms, and solve for it. So then if I distribute this, it becomes x squared plus 3x is equal to 10. And now this becomes a quadratic equation, so I can bring the 10 over to the other side, right? 3x minus 10 is equal to 0. And so now I need to solve for x. So again, this is our favorite part from that previous chapter, I guess in the beginning of the year that we've done so far. You can either do completing the square, you can do quadratic formula, binomial factoring, any method that you want, okay? So I'm going to go ahead and do binomial factoring. So let's see if it works. Hopefully it works. Multiplications of 10 is, what, 2 and 5? And if I make this a plus and a minus, let's see, that gives me a positive 5, negative 2 gives me a 3, positive 5, negative 2 gives me a negative 10, works perfect. Okay, So equals 0. So then x is equal to -5 and x is equal to +2. Now, here's the problem. When you get to these kind of problems where you just solved for it, you always have to go back and check to see, make sure that it actually works for both answers, okay? In the previous problems, we just go ahead and we just change it in forms and we're just manipulating it. That's okay. You don't have to check that one. But whenever you have to do some algebra to solve for x on this part right here, you always have to go back and check it to make sure it works. So where do I check it? So I take this and I put it back into the original equation, and we're trying to see if it actually equals to 1. So we're going to go ahead and do -5 first in here. So if I put in log -5 plus log -5 plus 3, and we're trying to see if it equals to 1. So this right here, I can bring it down to -5 log, and then -5, that will give us what's -2, and equals to 1. So now this is all calculator work again to see if it works. So you're trying to figure out if this works. So let's see. If I have log of -5, make sure it's negative, not minus. Log of -2, and it equals 2, it means it does not work. Okay, so then in your cases, I think on the scientific calculator, you'll get something like that where you'll get an error or you get some strange thing. It means it does not work. So then -5 does not work. So we do not make that work. And then we do exactly the same thing for, what is that, +2. So we check to see if it works for +2. So log of +2 plus log of, let's say 2 plus 3 is 5. And we check to see if that works right here. Okay, so then let's see, log of 2 plus log of 5, and it equals to 1. Perfect, it equals to 1 right here. So the only answer that works is this one right here. Okay, so you need to show all that work though, as far as the points goes, but then tell me at the final end, which is the correct answer at the end. Okay, so one more of those kind of problems right there. So which is then again solving part of it. So we continue on, we're going to go ahead and do this one. So this one right here, it's a minus right there. So that means that there's a division sign, right? So we have a log base 3. We have is then 2x minus 1 divided by, and then we have is x minus 4. So x minus 4 is equal to 2. And so again, we want to put into exponential form. So we're going to bring this over on that side right here. So you're going to have is then 2x minus 1 all over x minus 4 is equal to 3 to the second power, right? So 3 to the second power is 9. So then we have is 2x minus 1 all over x minus 4. So this is algebra 1 again. You can cross multiply this direction, right? Basically that's what you're doing, proportion. So if I cross multiply, this times 1 is itself. And then on the other side, it'll be 9 times x minus 4. So that gives me 9x minus 36 on this side, 2x minus 1. And we want to combine like terms on the x's. So let's see. There's more of the 9 on this side, but I guess it doesn't really matter. So we'll bring the 9x over on the other side. So 2x minus 9x is equal to negative 36. And then we'll have to add 1 on both sides, right? Add 1. So it's negative 7x is equal to negative 35. So then x is equal to 5, right? 7 times 5 is 35. Okay. And again, I would always go back and check this to make sure it works. So I would put it back in here. Actually, I can't put it back in here because this is base 3. Because remember, if you put in base 3, you can't put it in the calculator. So we would have to probably put it into this form right here. I think this would be the good place right here. So then you would put in, what, 2 is 5. So 2 times 5 minus 1 all over 5 minus 4. And the question is, does that equal to 3 squared? So that's not 10 minus 1 is 9 over 1 is equal to 9. So that checks. So we're good to go with that one. Okay. So then this is the final answer right there. Okay, so those are the problems that you'll be working with on this section.